So this chapter is about the second derivative, or this section, I should say, is the second derivative test, right? Second derivative test, which tells us about concavity. Okay, so there's two types of concavity. There is concave up, kind of cup holds water, right? Cup pointed up. Downward, concave down is kind of cup pointed down, right? Holds water and spills water. And then there's kind of this in the middle here, in the middle of concave up and concave down, or opposite, we have this kind of flat area where it's not concave up and not concave down. That's called an inflection point, where it changes. It changes from concavity one concavity to another. Okay. So we talked about how to find those inflection points. We did that. We did a couple examples, and then where it was concave up, where it was concave down, and where our inflection points were. And then we stopped here. Okay. So here, so this one has a denominator. Okay. So now we got to figure out, we got to do the same thing. Where is it concave up? Where is it concave down? And then where does it switch? If it's concave up and concave down, it's got to switch somewhere. Where does it switch? Those are inflection points. Okay. So anytime you see concavity, anytime you see anything about concavity or inflection points, anytime you see any mention of those, second derivative. That's always second derivative. It doesn't matter if it's a function like this, or if they give you a graph or a table, it doesn't matter. You always got to know, you always got to have second derivative. Okay. If you don't have it, you got to find it. Okay. So if I have the first derivative, so let's find the first derivative because they give us the original. That's the first thing we got to do. To find second derivative, you got to find the first. Okay. So the bottom squared, and then it's low, d high. Well, the derivative of the top is just 0. And then high, d low. Okay, and then we got to simplify it. So luckily, if it's times 0, everything that's times 0 is going to go away. So I would normally distribute property this, but it's just going to be times 0. So all that stuff's going to go away. So the only thing on top is negative 8x. Okay, that's the only thing that's going to be in the numerator. Okay, that's the first derivative. If they were asking us about increasing and decreasing, that's what we would use. But they're not. They're asking us about concavity. So now we got to find the second derivative on that. So this is going to be x plus 3 to the 4th power. It's squared. I'm squaring a square. What I'm doing is I'm squaring this part here. I'm squaring. So when you square a square, it's just to the 4th power. Okay. All right. So same thing, low. Problem is the low part here. How do I find the derivative? Oh, wait, so I just need the low. Let me do this first. I don't have to find derivative over here. So it's just x squared plus 3 squared times the derivative of the top. Well, the derivative of the top this time is negative 8. Okay. D high. So now I got to find the derivative, or so low d high this times the derivative of the bottom, the denominator. So if I'm finding the bottom of the the derivative of the denominator, how do I find that? What am I going to use? Which rule am I going to use here? Chain rule, yeah. We haven't used that one in a while, but yep. So we're going to use chain rule. So it's negative 8x times, and then the derivative, so I move the 2 to the front. Everything else stays the same. It loses a power. And then times the derivative of the inside, which is 2x. Okay, so there's a lot of stuff going on there. So I got to kind of simplify it before I can use it. So the bottom is just x squared plus 3 to the 4th power. Okay, the top, I can't do distributive property here. So right here, I cannot do distributive property here because it's squared. Okay, so it's just going to be -8 in front times x squared plus 3 squared minus. And then over here, I have a lot of multiplication stuff here. I have a lot of multiplication stuff. So I have this times this times this times that. Okay? So you can do a lot of things here. You can multiply these two guys or these three guys first, and then whatever you get, distribute it. You can distribute now and multiply with everything else. It's up to you. Okay? What I'm going to do is, since these are all coefficients, this is a coefficient, this is a coefficient, and this is a coefficient, I'm going to multiply all those three guys together. So what I get is -32. And then x squared plus 3. Mm-hmm. Yes, you're right. Yep, it would be squared. Yep. No, you were right. Yeah, because when I multiply -8x times 2, that's -16, and then I multiply it times a 2x, that's -32x squared. You are right. So now I can distribute. Now I can distribute here. So I got x squared plus 3 to the 4th power. I have -8 x squared plus 3 squared. And then over here I have minus -32x to the 4th minus 96x squared. Distribute the negative in front. So when I distribute the negative in front, that's just going to change all of these signs to positives. Okay. So once I do that, you don't need the brackets anymore. Okay. Okay. I could simplify more, but for right now, I'm just going to leave it. Okay. For right now, I'm just going to leave it because that's the second derivative. Okay. So before I can decide concave up or concave down, I have to find the inflection points. So how do I find inflection points for the second derivative? What am I going to do? What do I usually do to find inflection points for second derivative? Make it equal to 0. Yeah, right here. Right. Make it equal to 0. Right there in the bottom blue, that aqua color. Okay. So we're going to set it equal to 0. Well, since it's a fraction, right? Since it's a, put another. Right? The top is going to be what sets it equal, makes it 0. So if the top is 0, that's going to be 0. Okay, so the first thing I'm going to do is set the top equal to 0. So I have -8x squared plus 3 squared plus 32x to the 4th plus 96x squared. That's the top. So it looks like every part of this, every term has an This guy has an X. This guy has an X. This guy has an X. They all have X to some degree. So I can't really subtract or add anything to both sides. So what I have to end up doing here is I have to multiply this out. Okay, I have to multiply this out. So I'll do it to the side over here. So this part right here, I'm gonna do it right here. So it's what it is x squared plus 3 times x squared plus 3. Okay. So I multiply the first two terms, I get x to the 4th. Multiply the outside terms, I get 3x squared. Multiply the inside terms. I'm just doing FOIL here, multiplying them. I get another 3x squared. And then multiply the outside, I get positive 9. So when I combine, I get x to the 4th plus 6x squared plus 9. Okay, that's what I'm going to plug in for that guy. Now I can do distributive property. So let me rewrite this. I have negative 8 x to the 4th plus 6x squared plus 9 plus 32x to the 4th plus 96x squared. Okay. Now I can do distributive property. And then combine like terms. Okay, so combine the x to the 4ths. We got x to the 4th here and x to the 4th here. So when I combine those two guys, we get 24. Combine the x squareds, x squared, x squared. I get positive 48x squared, and then negative 72 equals 0. Okay. GCF. So now this is a trinomial. I got to solve a trinomial. So I could factor, or I could use quadratic formula. I think this one will factor. So first step, it's written right up there on the board, to factor any trinomial is GCF. Do they all have something I can divide by? A letter, a number, something I can use to make them smaller? Eight for sure, yeah. How about 24? Would 24 go into, I think 24 goes into 72 3 times, right? So yeah, even 24. When I do that, it makes it a lot smaller, which is what I want. If you divided them all by 8, it would still work. You would still get the same answer. If you didn't divide them all by anything, if you didn't do GCF, you would still get the same answer, but your next step would be a lot harder. Okay, so it's a trinomial on the inside. This is what I'm focused on right here. I'm focused on the inside. Okay, so to factor it, I'm going to see what goes into, so A times C. A is the leading coefficient, C is the constant, that's negative 3, times what adds up to be 2. So the two numbers that multiply to be negative 3 and add up to be 2, because 1 times negative 3 makes a negative 3, and that goes down there. So what multiplies to be -3 and adds to be 2? -1 and 3, yep. -1 and 3. Those are the ones I bring back in. So I'm going to bring it back in over here. The only difference is I'm going to break it down to x squared minus 1 and x squared plus 3. Now, why is it x squared instead of x? X squared minus 1, x squared plus 3. Why is it x right here? So right here, why did I put x squared instead of just regular x like we used to? Yeah. So in order for this to be mathematically correct, it has to multiply. So when I multiply these two guys, it has to be this guy here. And without the squareds, it wouldn't be. It would not work. Okay. Alrighty. So the last thing is to solve. So I have 24 times x minus 1 times, or sorry, x squared minus 1 times x squared plus 3. Each of those I have to set equal to 0. So I'm going to set 24 equal to 0. I'm going to set x squared minus 1 equal to 0. And I'm going to set x squared plus 3 equals 0. Everything that's being multiplied, I'm going to set equal to 0 because I don't know which one is 0. One of them has to be 0 because when they multiply, they make 0. When I multiply these three guys together, they make 0. One of them has to be 0. I don't know which one. So I got to assume that all of them are 0. Okay, well, the only one I know is not 0 is this one out here because 24 is not 0. So 24, check. I know that one's not 0, so I'm not worried about that one. This one over here, though, could be. So I'm going to add 1 to both sides. I'm going to get x by itself. So to do the opposite of a square is a square root. What's the square root of 1? That's half the answer. What's the other one? -1, yep. Anytime you're solving, and you take a square root, make sure you take into account both. Yeah. All right, this guy over here, -3. Take the square root, same thing. What happens when I take the square root over here, though? It's imaginary, yeah. There's no two numbers that exist on the number line that if I were to multiply both of them together, they would be -3. It just doesn't exist. It's imaginary. Well, in this class, we don't worry about imaginary numbers. Math 2 and Math 3, we definitely talk about imaginary numbers. But math and calculus, we're not focused on imaginaries. We're just focused on the real answers. Okay? So the only real answers that I get are right here. So those are 2 of my critical values, which are also going to be inflection points. Okay. So those are 2 of them. Now, where else do I have to check? I checked the top. Now I got to check the bottom too. So look at the denominator of the second derivative. So go back to the second derivative. Right, yeah. We did the top. The ugly part was the top. The bottom part was x squared plus 3 to the 4th power. Why do I not have to check the bottom? You should, but why mathematically do I not need to check the bottom, set it equal to 0, and solve it? No, because it can't equal 0. Yeah, it cannot equal 0. We've seen one like this before. Any number. Is there any number I plug in for x here that after I square it, after I add 3, and after I take it to the 4th power, Is there any number where it would be 0? Oh, -3. Well, if I plug in -3, it's going to be 9. 9 plus 3 is 12. 12 to the 4th power is some big number, right? There is no, you could do it. You could do it. If you want to try it, you could say x squared plus 3 to the 4th power equals 0. And then solve it. You would take the 4th root, and then you would subtract 3 from both sides, and then you would have the same thing we had here. It's an imaginary number. The number is imaginary, that makes it 0. So we don't worry about imaginaries. Imaginaries we don't concern ourselves with in this class. Okay. So the only critical values are -1 and +1. Those are the ones I have to check for positive or negative. Okay. So let's draw a number line. I got a -1 and I got a +1. So I'm going to plug in numbers that are to the left of -1, in between -1 and 1, to the right of 1, to see if it's positive or negative. I'm going to check it with the second derivative. Now again, I don't care what the answer is. I just want to know if it's positive or negative. So when I plug in, let's plug in a number. When I plug in, let's plug in f double prime of -2, since it's left. I'm not even going to plug it into the bottom. Why am I not going to plug it into the bottom? Why am I not going to plug it into the bottom of this guy here? Why am I not even going to worry about plugging in anything to the bottom? It's always going to be positive. It's always going to be positive. Yep. So that'll save you a little bit of time. So this answer is always going to be a positive number. But I do got to plug it into the top. Okay. So when I plug in -2, you might be able to do this in your head. If I plug in -2, I got to plug it in here. And I got to plug it in here. And I got to plug it in here. Okay. So over here, I get -2 squared, which is 4, plus 3 is 7, squared is 49. Okay. And then I multiply 49 by -8. 49 times -8 is going to be -2 something, -200 and something, right? And then over here is positive and positive, right? Which side is going to be bigger? The left side over here, or when I plug it in -2 over here? Because over here it's going to be a positive number, right? Square -2 to the 4th -2. -2 squared is 4. -2 to the 4th is 16. This side's going to be a lot bigger than this side here when all is said and done. Because this is 16 times 32. 16 times 32 is 500 something. And then 4 times 96 is 400 and something, or 300, just under 400. So this side over here is going to be bigger. So the positives are going to win out. Okay. So it's going to be a positive here. It's positive over a positive. So positive divided by a positive makes a positive. Okay. So if you're looking at your notes one day and you're like, wait, why didn't we multiply it out? Rewatch the video and see. We did it in our head, but I'm only concerned about signs. I'm not concerned about actual values for the derivative test. Okay, 0, plug in 0. 0 is easy because it makes everything 0. Everything that's multiplied will be 0, right? So if I plug in 0 over here, it's going to be 0, gone. Same thing over here. Gone. It'll only leave this part over here. So if I plug in 0, 0 squared is 0, plus 3 is 3. 3 squared is 9. 9 times negative 8 is negative 72. So you would have negative over a positive, which makes a negative. Okay. And then the last one, plug in positive 2. Well, I'm going to have a positive on the bottom. We know that. When I plug in positives, it's going to have the same, it's going to get the same number that I got with the negative 2. Because this one's going to have negative 2 squared and positive 2 squared are the same number. Negative 2 to the 4th power and positive 2 to the 4th power are the same number. Same thing here. I'm going to get the same number I got there. Okay, so that's why this will have the same answer. So it'll be positive. Okay. Okay. Done with the problem. Now we got to sum it all up. Okay. Concave up. Where it's positive. So concave up, negative infinity to negative 1, or positive 1 to positive infinity. That's where the pluses are. Concave down is in between. And then we got inflection points. Inflection points at x equals negative 1 and x equals positive 1. Okay. All right. So the longest part of that problem had nothing to do with calculus. It was this part here, right? It was this part here, which I'm doing in Math 3 right now. So it's not the calculus part that sometimes takes the longest. Calculus part we were done with up here. When we found the second derivative, calculus is done. And then we came back for the calculus for the number line. That didn't take that long either, right? So a lot of times those things won't be the calculus that takes you the longest, or it won't even be the calculus that's the hardest part, which is crazy. But okay. So here's a little cheat sheet. So how can you use this cheat sheet? Well, this one mostly will help you probably with more tomorrow, what we do tomorrow, because tomorrow we're going to look at more at graphs tomorrow. Tomorrow we're not going to really focus on equations. We're going to look at graphs. Because if something is increasing in concave up, that means the derivative is positive, first derivative is positive, and the second derivative is positive, right? If something is increasing and a possible inflection point, see, it tells you like what if you have something, if you're looking for an inflection point, because sometimes what we're going to do tomorrow is I'm going to give you a graph of the first derivative. And then I'm going to say, okay, where are inflection points? Where is it concave up? Where is the original concave up? Where is the original concave down? This is going to help you do that because this is what you're looking for here, right? If I want to know where the original is increasing in concave up, I'm going to go find where the derivative is positive and where the second derivative is positive, here and here. Or if I want to know where it's concave up or where there's a relative minimum, where is there going to be a relative minimum? Well, when the first derivative is 0 and the second derivative is positive. Okay, so it's more of a cheat sheet It'll help us more tomorrow, but I wanted to put it on there because it will help you because of questions you will see. Just like the one on the bottom here. You're looking for something, I'm looking for where it's decreasing and concave up. Decreasing and concave up. So decreasing is here, right here. So I'm looking for where it looks like that, where the first derivative is negative, but the second derivative is positive. Okay? So to do the next one, we need both first derivative and second derivative because you see decreasing, increasing, decreasing, automatically first derivative. Concave up, automatically in your head, second derivative. So what I want you to do right now is find both of them. Find both of them right now. Okay, check. So the first thing we're going to do is check for increasing, decreasing. We're going to check to see where it's increasing, where it's decreasing. So to do that, we're going to use the first derivative. We're going to set that guy equal to 0. Okay? So right. Again, it's a trinomial. We have to solve it. So that's why I haven't taken down these. In my Math 3 class, we're kind of past that, but I put it up there because it always comes back. In that class and in this class, it always comes back to this, those solving trinomials, okay? So the first thing we got to do is set it equal to 0, done. That'll be done for you. Next thing is GCF. Is there a GCF in negative 60 and 54? 6. If you're solving and you don't do the GCF, it won't hurt. But trust me, the next step is going to be a lot easier if you do GCF. Because the next step is multiply the first term, the leading coefficient of the first term times the last term. And it's a lot easier to multiply 1 times 9 than 6 times 54. Okay? So we get 1 times 9 is 9. The b term, the term in the middle, is negative 10. Okay? So what multiplies to be positive 9 but adds up to be negative 10? Negative 1, negative 9. These guys don't need squareds because this is squared. It's not to the 4th. Okay, so we get 2 answers. What do we get? What are 2 critical values? 1 and 9. Positive 1, positive 9. Those are our first derivative critical values for first derivative. Okay, first derivative test, number line. We got positive 1, positive 9. I only care where it's decreasing, right? I'm only looking for decreasing. That's where I need to focus on. Now, I'm going to check all of it, but I need to focus on decreasing because I need to know where it's decreasing and concave up. Okay. So first derivative, if I plug in, you can plug in for first derivative, you can plug it into any one of these guys because they're all the first derivative. One is just factored, one is not. Okay. So if I plug in 0, if I plug in 0, if I plug in 0 here and 0 here, I'm going to get a negative there, I'm going to get a negative here. Negative times a negative makes a positive, times a positive 6, I'm going to get a positive. One and 9, 2, 3, 4, 5, any of those numbers. Okay, so pick 2. If I plug in 2 here, 2 minus 1 is positive, 2 minus 9 is negative. So a positive times a negative times another positive, you get a negative answer. Okay, after 9, 10. So if I plug in 10 here, if I plug in 10 here, I'm going to get a positive 9 here. I'm going to get a positive 1 here times a positive 6. You get a positive again. Okay, so my focus now is right here. That's my focus. My answer is not going to be greater than 9. My answer is not going to be less than 1 because the question says it's where it's decreasing. So the only place it's decreasing is between 1 and 9. Okay, so the nice thing is these types of questions are going to be multiple choice questions, and right there you can already eliminate probably at least 2 of them, at least 2 or 3 of them. If there's 5 different answers, you can probably eliminate 2 or 3 of them because the answers won't be between 1 and 9. Anything not between 1 and 9, cross out. Can't possibly be. Can't be greater than 9 or less than 1. Okay, so our answer is going to be somewhere between 1 and 9. To figure it out, I got to go back to the second derivative. So the second derivative, this is just linear. It's going to have one answer. So if it's just got one x, you add 60 to both sides. You guys have been doing this, I think, since 7th grade, 6th grade. Divide by 12. You get x equals 5. So that's the critical value for f double prime. Okay. So now we got to check to see where is it positive? Concave up? Yeah, concave up. Where is it positive? To the right of 5 or to the left of 5? This one you can probably do in your head because it's just linear. So you're going to plug in 6, 7, 8, whatever number you want to plug in over here. You're going to plug it in to the second derivative here. I'm going to pick 10 since 10's a nice round number because 10 is over here. So I'm going to pick 10. So when I plug in 10 here, that makes 120. Minus 60 is a positive number. Okay. Plug in a number less than 5. 0. If I plug in 0 here, that's 0. Minus 60 is a negative number. So this is where I'm focused on here. Use a different color. Now my question is, where do those overlap? If I were to put this guy on top of this guy, or opposite, if I were to put one number line on top of the other number line, where would they both be shaded? Where would they both? I'm looking for where they both have shade, not just one. I can probably do it. There you go, 5 to 9. All right, right there. They both have shade at 5 to 9. So that's the interval where they're decreasing in concave up. Decreasing and concave up, 5, in between 5 and 9. That's it. Okay, so it's just nothing we haven't done. You're just combining them together and comparing the number lines. You're doing what we did for first derivative test. You're doing what we did for second derivative test, and you're just combining your answers to see where do they overlap. Okay, so let me skip a couple because, okay, look at this example here. Look at this example. We're not going to do this example, but I put it on here because I wanted to make a point. This example here, it says, you will see problems like this. You will see problems where it says, use the second derivative to find relative extrema. We've done that before. We've found relative extrema. We have found relative extrema. You guys had a homework assignment on it already. What did we use to figure those out? How did we do it when we did those assignments last week? Or it might even be a week before that. What did we do to find relative extrema? What did we use? What did we do? What did we, relative extrema, maximum, minimums? First derivative test, right? Here it says use the second derivative test. We don't use second. It is possible to do it, but it's harder that way. So what I tell students is do this. Cross this out and say first derivative test and do it your way. You won't be docked for it. You will not be docked for it. You know why you won't be docked for it? Because these are multiple choice questions. You will see this on a multiple choice question. I've never seen that question on a free response question. It'll always be a multiple choice question, and process doesn't matter on multiple choice, right? So whatever process you want to do. So this problem is just like we did last week, the week before, whenever we did these notes. So do it that way. Find the derivative, set it equal to 0, number line, where is it positive, where is it negative, increasing, decreasing, kind of thing. Okay, we're not going to do this problem because, like I said, we've already done this problem. But since we were doing second derivative tests, I wanted to bring this up. Common question: use the second derivative test to find relative extrema. No, don't do that. It's a lot easier to use a first derivative test. Okay. Same thing with this question here. Same thing with this question here. First derivative test. Okay. Okay, so let's see. There's 2 more that I definitely want to cover before I'm done with this. Let's start on this one here. We won't finish it, but we'll finish it tomorrow. This one here. It's right under the one we just did. Right under the one we just did. Or the next problem, if it's on the next page. Find all intervals on which this guy is increasing. Well, again, this is a problem we've done before. This was a first derivative test problem because it just says increasing. Doesn't say anything about concave up or concave down, just increasing, right? The reason I put it in is because it has E, and we haven't done a lot of E questions, and you'll see a lot of those types of questions. So I wanted to do one with you guys to show you. You guys have done it before. You guys have done derivatives with E, so it's not that bad. But I wanted to do one together. Okay? Okay, so we got to find where it's increasing. So if there is nowhere where it's increasing, we just leave an empty answer. Empty answer means that's our answer. Okay? So let me write down -4x squared plus 3x, and then I have e to the -2x. Now there's two ways to do this. I need to find the derivative, right? So there's two ways. The first way is use quotient rule. You could use the quotient rule, that'll work. The second way is I could move the bottom to the top, right? I could do this, -4x squared plus 3x times e to the +2x, right? If I move it to the top, you could do it that way, and then use the product rule, right? Doesn't matter which way you do it. Doesn't matter which way you do it. You're going to get the same answer both ways, okay? Whichever way you do it is fine. All right. So let me try this way. Let me try the quotient rule, since I think most of you guys probably use quotient rule. Okay. Bottom squared. Okay. Low times the derivative of the high, which is -8x squared, or sorry, 8x plus 3, -8x plus 3. High, x plus 3. D low. How do I find derivative of anything with a e? What's the rule for finding a derivative with an e? There's two things I got to do. What's the first thing I got to do if I'm finding anything with a derivative of e? What's the first thing it does? Repeats itself. Good. And then what do I do next? Take the derivative of the power. Good, which is -2. Okay, so let me clean this up a little bit. The bottom. If I have a power to a power, what do I do with those powers? Multiply them. Yep. So you're going to get e to the -4x. The top. The top here. See here, I can do distributive property. I can distribute the e to the -2x. And then over here, I can multiply these two guys and then do the same thing. So let me do that. So I'm going to distribute this guy, distribute that guy. -8x, oops, e to the -2x plus 3 e to the -2x minus. So I'm going to multiply these guys first. So it's going to be -2 e to the -2x. And then I'm going to distribute here and distribute there. So it's going to be +8 x squared e to the -2x minus 6x e to the -2x. And then I got to distribute the negative, which will make that negative and that positive. And then I don't need the brackets anymore. I have some like terms. I can combine some like terms. This is the last part we'll do. I have some like terms here. I have this guy here. Use a different color. And this guy here. Those both have x e to the -2x. Those are like terms. So I can add them to make -2. plus 3e to the negative 2x minus 8x squared. All right, then that's the first derivative. So tomorrow we'll figure out how to solve it. Okay, tomorrow we'll figure out how to finish solving that. Okay.